So hi everyone, today we'll be discussing the problem D from latest Codeforces round 113 division 2 educational round. So what does the problem says? So problem says that there is a city that can be represented in the form of a square grid with corners 0 0 and 10 comma 6 comma 10 comma 6. So if you look at it like this, so it looks like it can be 0 comma 0, this point can be 0 comma 0, and this point can be regarded as 10 to the power 6 comma 10 to the power 6, right? So this is a square grid. This seems rectangle, but just assume that I have made it rectangle for magnification purpose. And what it says is there are n vertical streets and m horizontal streets. So the number of vertical streets are n, so this is n, and the number of horizontal streets, the number of that means this means that this will be m, because the number of horizontal street, so this is a horizontal street, this is a horizontal street, so this will be shown here, and the number of vertical streets are n. So this is a vertical street, this is also a vertical street, this is also a vertical street, right? And next up it says that after this what happens is the ith vertical street goes from xi 0 to xi 10 to the power 6, right? So that is quite clear. So ith vertical street, so what is a vertical street? The vertical street is this, so it goes from here till here, so from 0 0 to 10 to the power 6. So it is not like that if a street is starting, then it is not like if a vertical street is starting that then it will be from here to here only. This is not the case. It is simple that if you will have a vertical street, then it will be from 0, x is equal to 0 to x is equal to 10 to the power 6, right? So this is quite clear, I hope so. And then nextly what is given in the question is that the streets are bidirectional, so you can move from both the directions, either from left to right, in case of horizontal from left to right, or left or right, and in case of vertical you can move up or down as per the situation demand. So there are k people standing on the street, and the pth person, let's suppose that there is a pth person, then his coordinates are xp comma yp, right? So xp is xi and yp is yi, same as both, or same both. And let's say that the uh, pair of persons forms an inconvenient pair if the shortest path from one person to another going only by street is strictly greater than the Manhattan distance between them. So I'll come to this and explain you the Manhattan distance in a visual manner as well. So let's look at the test cases. So you have been given n, m and k, and then you have been given x and y, where xi is the vertical street and yi is the horizontal street, right? So if we look at this test case, then 8 comma 5 is a 8 comma 5, the point number 8 and the point number 5. So what happens here is, if you have 8 and you have somewhere 5 here, let's assume that you have 5 here. So let's say this was the 8 and this was 5. So what would be the Manhattan distance between them? The Manhattan distance would be simply, uh, let's assume, let's take let's take a test case where I'll be showing you what the Manhattan distance actually is. So the Manhattan distance is, let's suppose that this point was x1 comma x2 y2, and this point was x2 comma y2. So the Manhattan distance will be x mod of x1 minus x2 plus mod of y1 minus y2, right? So what happens is you will have to cover this distance. This is the Manhattan distance, right? This whole is the Manhattan distance. I hope that you are aware of this. I'm assuming this. Then what happens is you have to find all the inconvenient pairs, you have to find inconvenient pairs, and the definition for inconvenient pair is such that you have to find inconvenient pairs uh, such that the definition is that for them the shortest path for them should be greater than the Manhattan distance between them. So I'll come up with an example for you. So let's assume that between two particular verticals, these are the horizontal streets. Then for this horizontal street, what will be the Manhattan distance? What will be the Manhattan distance? The Manhattan distance will be mod of x1 minus x2 plus mod of y1 minus y2. That is clear. But what will be the shortest distance between these two? So you can move here, then you can move up, and then you can move left. So this will be the distance between these two. Similarly, for this one, let us suppose that if you had to move from this guy to, let's suppose, this guy, then what you will do is from this person to this person, you will move first towards the left, then you will move down, and then you will move uh, right. So you will move right. So in this way you can see that this is greater than the Manhattan distance, and you can check it geometrically also using this formula. So this is the Manhattan distance, and is this let's suppose for these two people, for this person and this person, you move from left to right or right to left in any way. So is this the shortest distance between them greater than the Manhattan distance? No, for this case it is not true, because both are lying in the same street, vertical street. So you can see that if you want a person to be at a distance more than him, like for this and this case, what will happen is the shortest distance between these two will be from the here to here, right? So this is so you can see that this is greater than the Manhattan distance between both of them. So this is what the question demands. So you have to find all such pairs which are called as inconvenient pairs, such that the shortest distance between them is greater than the Manhattan distance. So what you can do is you can apply binary search, because binary search will will help you in finding all the number of pairs. And what you will be doing is simply for these two, let's assume for these two vertical rows, you will see that there will be horizontal columns lying in between them. So for all such horizontal column, for a person in a horizontal street, for you will find all such horizontal people in the horizontal street. And here the problem will be that, let's suppose there will be a guy here, so both of these are in same, so you will not be counting these two, instead you will count this. And let's suppose that there was another person here, so you will count this pair and this pair. Similar way, what you will be doing, you will be counting all pairs. So this was all about the question. We'll see the sample test case as well, and then we'll move towards the code. So let's say that this was the case, then what happens is you can see that the point number 3 and point number 4 here, these 2 points are inconvenient pairs. These 2 points are forming in an inconvenient pair. How they are forming, I'll show you. So what is happening is these 2 pairs, these 2 numbers, let's suppose that there is this number, this element, this guy here, and there's this person here, this person right here, you can assume him to be here. So what happens is you can see that what you will be doing is you will first move up, then you will move towards the right, and then you will move towards down, right? Up again. So this is the shortest distance between them, and it is greater than the Manhattan distance between the two. So this is one such pair. And then again, let's see another pair that can be here. So the other pair is 3 comma 5. 3 right, 3 comma 5 is another such pair, because again the shortest distance between them is greater than the Manhattan distance between them. Again, you can, if you want, you can calculate them geometrically. So I'll move to the coding part. So first of all, you will take n, m and k as input, then you will declare a vector for two vectors, for one for horizontal and another for vertical, for taking the inputs. Then you will have two maps. One map will be for a to a comma b, and another map will be for c comma d, then you will take all the verticals as input, then you will take all the horizontal people on the horizontal streets and input as an input. Then to apply binary search, what you will be doing is you will be sorting both horizontal and vertical vectors, and then you will be pushing 1e7. Why 1e7? Because as you know that the points start from 0 comma 0, 0 comma 0, and it ends till 1e6 comma 1e6. So this was the coordinate. So since you want to apply binary search, so what you can do is you need to have one more extra index such that it is not present in the array. So this is 1e7, which is, as you can see, it is not present in both horizontal and vertical vectors. So what you will be doing is you will take all the k as inputs, and you will take the pair u comma v. For each time you will take input u comma v as a pair, and then what you will do is you will do a binary search for both vertical and horizontal street. So in a vertical street, if you do a binary search in a vertical street for that particular pair, so what you will do is you will find a k such that it is upper bound for u, right? I am assuming that you know about the upper bound function. Then you will update the frequency for k, and you will also update the counter for the particular value yi, or the yth coordinate of the given point, right? And then similarly you will do the same thing for horizontal as well. Then what will be the number of pairs? The number of pairs is n into n minus, what is the as you know that for finding number of pairs you do n into n minus 1 by 2. So you will do both, you will do this for both a and b, for both pairs, like for both the maps a and b, and you will also be subtracting some numbers. So what are the numbers, or what are the pairs? There will be, you are counting total number of pairs, but again you will be subtracting some of the pairs. So as I have discussed earlier, what are those pairs? So I'll show you once more. So let's suppose that these two elements lie in a particular this and this elements lies in a particular horizontal street. So what happens is this pair will also get counted. So to neglect this pair, you will be subtracting in the end for both horizontal and vertical. So in this way you will be counting all such pairs. So this is the code for this is the accepted code for the question. So in case if you have any doubts related to this question and the code, you can mention that in the comment section, and I'll get back to you as soon as possible. Thank you.